Okay, so I'm going to record Chapter 3. Chapter 3 is called The Basic Skills of the Biotech Workplace. So it talks about measurement and how we do calculations to make solutions. So there's just the heading. Okay, so the first thing, and this is going to definitely be a review, is about volume. So volume is just a measurement of the amount of space that something occupies. So if you look here, you will see that, let me see. Oops, not that. Sorry. Get rid of it. You can see that here's quarts and 32 ounces, and then here's a liter and 29.4 ounces. So volume is pretty straightforward. Whoops. Okay, so in a lab, when we talk about volume, most of the time we use the metric system. So in a biotech lab, most of the time we're working with liters. We could also be working with milliliters or microliters. Okay, so a milliliter, here's the conversion. So a milliliter equals 0.001 liters, or 1,000 milliliters equals a liter. So the conversion that I usually use is 1,000 milliliters equals 1 liter. So there's that. Okay, now a milliliter's worth is about a half a teaspoon if you measured it out with English methods. Okay, now the other unit that we use a lot is itty bitty, teeny tiny, and that's a microliter. Okay, so a microliter, so it's a mu, a lowercase mu, so it's a U with a little hooky thing on it, and it's micro is what it's called. Okay, so it's 1,000th of a milliliter. Okay, so it's smaller, even smaller than a milliliter. If you measured out a microliter, it would fit, the little drop would fit on the top of the head of a small straight pin. So it's really tiny. A normal drop that might come out of the sink or something is about 10 microliters. So microliter is really small. Those are the volumes that we work with because most of the solutions that we deal with are very expensive, and if we can do them in small scale, it costs a lot less, and we can do a lot more samples in a smaller space. Okay, now, whoops, I keep forgetting to put the finger thing up. Okay, now this is kind of a review, so lots of times volumes are measured maybe in one unit, but then when we report them in another. So lots of times we just have to do conversions using the metric system. So that's pretty straightforward. It's not hard. Metric units are really easy to convert with because they're all base 10. So this metric scale has a lot of different things on it. So for the most part, we use milliliters. We might use kiloliters. Okay, we use micro, and sometimes we use nano and pico if we're working with really small PCR products. Okay, but those are the ones. So now if you look at the metric scale, you have to remember that where this none is, well, you can put a base unit after this. So you might have liters for volume. You could have mass, or grams for mass. Okay, or you could have well, those are the two that we work with, liters and mass, liters and grams. Okay, so our book uses this little rule, and I personally don't use it, but they're saying it's a BS rule, and it kind of tells you what way to move the decimal point. So if you're converting from a bigger unit to a smaller unit, you're going to go from, you're going to move the decimal point to the right. And if you're going to the left, you're making it smaller. Okay, so if I took 1.25 liters and I wanted to make it milliliters, and milliliters are smaller, I would move the decimal point over 1, 2, 3. No, that's wrong. I'd move the decimal over 1, 2, 3 because I'm going from small to large. Okay, so this doesn't make any sense. See, I never use this. Okay, hold on. Let me erase it. Let's try this again. I don't want to start over at the beginning. Okay, so if we do it using, okay, 1 liter equals 0.001, not 1 liter, 1 milliliter equals 0.001 liters. Okay, and we say we have 1.25 liters and we want milliliters. We're going to need to go to the right to make it, to get to the smaller units. So we're going to go 1, 2, 3, and that would give us 1,250 milliliters. Okay, there's another way to do it. I just didn't learn to do it this way. I learned to do it with dimensional analysis. So if you learn to do it this way, it's easy for you. But okay, so let's see. Dimensional analysis, what you do for it is you use a conversion factor. And I want to try to get rid of this. I still have this arrow on here. Okay, so to try to use a conversion factor, all a conversion factor is it's a fraction where the numerator and the denominator are equal to the same amount. Okay, so for example, 1,000 milliliters is equal to 1 liter. Okay, so you can flip it if you need to because it's equal to the same thing. So for example, this is set up weird because it's typed, but you could take 1.25 liters and you wanted to figure out how many milliliters you have. You multiply it 1,000 milliliters over 1 liter. Okay, and you can cancel out your liters, and then you just multiply 1.25 times 1,000 and you get 1,250 milliliters. So hopefully that makes sense. Okay, so when you're converting, this says when you're converting to a larger unit, divide it by the conversion factor. So if we do this, so when I set up these equations, I always start out with what I'm looking for. So X liters, okay, and then what I'm trying to, what I know I have, so I have 75 milliliters. Okay, and then I want to get to liters, so I want to use this conversion factor up here, and the way that I do that is I want to cancel out milliliters, and I want liters. So I'm going to put the liter on top, and the 1,000 milliliters on the bottom. Okay, and then I can take 75 and divide it by 1,000. So 75 divided by 1,000 is going to be 0.075 liters. Is that right? You always check your math, right? But I think it's right. Yeah, that's right. And you always have to remember to put your units on your answer so that it gets marked right. Okay, now when we're measuring volume, there's different instruments that we use. So one instrument that we use is called a graduated cylinder. So graduated cylinders, they come in a variety of sizes. So we usually, we have some that are 2 liters, we have some that are 1 liter, and they can go all the way down to 10 milliliters. Okay, these are called graduated pipettes. Okay, and they kind of work the same way, but what they'll do is there'll be a pipette bulb up here, and you'll use it to suck or aspirate the liquid up, and then you can use the little increments on the pipette to measure your volume. Okay, and they come in a bunch of different sizes too. Usually we use these for volumes that are less than 25 milliliters. Okay, now this is what we have. These are micropipettes. Okay, and micropipettes, if it makes sense, right, they're used for small volumes. So they come in different sizes. So we have, for the most part, they start at about 1,000 microliters. So that would be a milliliter, and then they go down from there. For these, you put on a disposable tip. You put the tip on, you'll aspirate the liquid up into the tip, and then you'll eject the liquid out of the tip. So they're perfect for measuring small amounts. They're really expensive. They're about maybe $250, $300, $400 a piece. Okay, so whenever we use a graduated cylinder. We mainly use them when we're measuring volumes larger than 25 milliliters. Okay, so what you're looking for when you measure them is you make sure this is on the bench, you put the liquid in, and then you're going to measure the bottom of the where the liquid is in there, and that bottom point is called the meniscus. So it's really important that you measure at the bottom because that's the most accurate place. That's where you measure. Okay, so now here's graduated cylinders. They're they're usually labeled. Okay, so they have the size on them, and then they have them, the increments or the graduations on them. It's like this one, so it's goes from 0 to 10. So if you let all the liquid out, that'll be 10. So we usually use them from 25 mils down to about a milliliter. So they come in units. So there's 25, there's 10, there's 5, there's 1 usually. We use pipette bulbs or these little pumps to pull the liquid up into them. In the old days, they used to put their mouth on them and suck, but we don't do that anymore. Okay, so you don't ever mouth pipette. Okay, here's the micropipettes. So here's what they look like. There's 3 different sizes. Different companies, they look different. We have both this and the last one in our lab. So this one's probably 1,000, this one's probably 200, and this is 20. And what they're measuring in is microliters. So they're measuring really, really small volumes. So they have to be very precise. They have to be calibrated frequently so that we know that they're measuring the right amount. Okay, so if you look at the pipette, the micropipette, and I know some of you probably use these maybe in chemistry or biology, or maybe in high school. Okay, so if you look at one, there's got 4 main parts. So the plunger is the little button on top, so this is going to move up and down. Okay, there's an ejector button, so that's the ejector button. When we push that, it's going to push the tip off. Okay, it's got a display where it's going to show you, what the amount you're working with. So if I wanted to measure 100 microliters, it would say 100. Or actually, this one is a P1000, so it would actually be measuring 1,000 microliters. The tips on the bottom are disposable. They're plastic tips. We buy them, we keep them in little boxes, and we autoclave them to make sure that they're sterile. Okay, so when you use a micropipette, what you're trying to do is you're going to try to pick one that's going to measure the volume that you want. And most of the time they have the volumes, the maximum and the minimum volumes on them. You want to make sure that you're working in this range in order for it to be accurate. So the maximum volume this one can hold is 200 microliters and the minimum is 20. So you don't want to go above it or below it. So when you look at this, okay, you can determine the volume. Okay, so there's the hundreds, there's the tens, there's the ones, okay, and then it'd be, what is it set at? I can't, so like maybe 0.2, but this, 0.5, because it's in between the 1 and the 1 and the 0. Okay, so there's the volume. These numbers are like estimates. They're not very accurate. Okay, but this is accurate. Okay, so the P200, and they always put P in front of them because it's like for pipette. But some companies, like one set that we have in lab is like the M200. Okay, so the P200 can measure between 200 and 20. Okay, so you wouldn't use it for 10, you wouldn't use it for 250. Okay, so here's some of the things that make them different. So each manufacturer shows the units on here a little bit different. Most displays show 3 numbers, and the top number is the digit where the maximum volume is going to be. So if this one did 200, this is what it would look like. There's a knob on them. Sometimes it's at the top, sometimes, most of the time it's on the top. that you turn to adjust it. If you go above or below the limits, it'll break it. And then it's not good anymore. It has to be fixed. Okay, so here's a little pipette. So here's a P10 or P20. So this one's supposed to actually be P20. Okay, so the maximum it can measure is 20 and the minimum it can measure is 2. Okay, so when you're using these pipettes, you want to make sure that what you're measuring in is you're using the smallest one closest to what you can do. Okay, so like I might be able to make the 200 go down to 20, but the 20 is more accurate for doing this job than the 200 would be. Okay, so the P1000, so P1000, 1000 microliters is the same as 1 milliliter. Okay, so this is measuring a milliliter, about a half a teaspoon. Okay, now this one, this is the top number. This is where it gets tricky. So that's 1, 0, 0. Okay, so there'd be another 0 down here, okay, to make it 1,000. Okay, now, in some labs we have electronic pipette. Okay, so when we're using these, we're using our thumb on this piece. Okay, and it can create, if you're doing the same volume over and over again, it can cause repetitive motion injury. So there are pipettes that are electronic, so you just plug them in and recharge them, and you can push a button and then it's going to pipette the same amount over and over again. So there's electronic pipettes. Okay, so there's an example of electronic. Here's multi-channel pipette. So lots of times we use 96 well plates. So there's a whole bunch of little holes on the plate, so we can put like 8 to 12 tips on a pipette and pipette 8 to 12 samples at a time. Lots of places where they do large scale, high throughput, there's a pipetting machine. So if you're using the same buffer, here's all the tips. It's shaped like this 96 well plate. Okay, and you just put it in there and the robot will suck the liquid up, and you don't have to do it yourself. I've never been lucky enough to work in a lab like that. Well, I guess maybe I haven't had to do that big throughput. Uh-oh, what's going on? Okay. So that's the last slide.